Hi students, welcome to JSR Maths Academy. Today we are going to discuss about one more important topic of your maths, that is of surds. Okay, so let us see the definition of surds. Let A be a positive rational number and n be a positive integer which is not equal to 1, then if nth root of A or A to the power of n is not a rational number, then nth root of A is called as a surd of order n or nth order surd. Okay, if you see the question, if you see the definition, A be a positive rational number. A be a positive rational number. N is a positive integer which is not equal to 1. If nth root of A, or A to the power of n, both are same. Okay, nth root of A can be written as A to the power of 1 by n is not a rational number, then nth root of A is called as an surd of order n or nth order surd. Okay, so to say this in simple words, if you take a number, if you take a rational number A, if it cannot be written as a nth power of any other number, if it cannot be written nth power of any other number, then nth root of A is called as an surd with order n. So let me take a simple example. If you take a number 36, 36 is a rational number and 36 can be written as a 6 square, but it cannot be written as a cube of any other number. It cannot be written as third power of any other number. So if you take a cubic root of 36, if you take cubic root of 36, this cubic root of 36 is said to be as a surd. This is said to be what? Surd of order 3. But if you take a square root of 36, which is of 6, which is a rational number, that's why square root of 36 is not a surd. Okay, do you understand? In the same manner, if you take a 16 is a, so 16 can be written as square of 4. So square root of 16 is not a surd. But if you take a cubic root of 16, that means 16 cannot be written as a cube root of any other number, or 16 cannot be written as cube of any other number. So this is said to be as a surd. This is said to be as a surd. Okay, is it clear now? This is the definition of a surd. Okay, now in this surd, what is the other name of surd? Other name of surd is radical. Other name of surd is radicals. Okay. Now in this the symbol nth root of A, nth root is called as a radical sign. This is said to be what? Radical sign. And here n is called what? Order of the surd. N is equal to order of the surd. N is called as an order of the surd. And if you take a surd of nth root of A, if suppose nth root of A is a surd, then in this A is called as a radicand. A is called as what? Radicand. Okay. Now here if you take a nth root of A, this is how I write. That is as a, I read it as an nth root of A. Nth root of, we need to read it as an nth root of A. What are the examples of nth root or else surd? Means if you take a square root of 3, okay, square root of 5, okay, and square root of 7. Likewise, if you take a square root of every prime number is a surd. Was it clear? Now you can take a square root of 3 by 7. This is also surd because 3 by 7 cannot be written as a square of any other number. So square root of 3 by 7 is also a surd. And let us see few more important concepts regarding this surd. If they mention that if nth root of A is given to us, and let us suppose A can be expressed as an x to the power of n. If A can be expressed in the form of x to the power of n, then nth root of A can be written as nth root of x to the power of n which is of x, which is a rational number. That means a should not be represented as a nth power of any other number. If it's so, then nth root of a becomes a rational number, which is not a surd. Okay. Now, every surd, one more important concept, that is every surd is an irrational number. Every surd is an irrational number. Every surd is an irrational number. But converse is need not to be true. Converse is need not to be true. That means every surd is need not to be a every irrational is need not to be a surd. Let us see an example for that. If you take a square root of 2, which is a surd and which is of irrational number, but if you take a pi, number pi, which is an irrational number, but it is not a surd. It is not a surd. Okay, pi is not a surd, but pi is an irrational number. That's why every surd is said to be an irrational number, but every irrational is need not to be a surd. Okay, now let us see the types of the surds. Types of surds based on order. Okay, first type is quadratic surd. First type is what? Quadratic surd. Quadratic means what? Quadratic surd means what? A surd of order 2. A surd of order 2 is said with what? Quadratic surd. A surd of order 2 is said with what? Quadratic surd. Example, if you take square root of 2, square root of 5, square root of 3 by 7 and square root of 15. These are the examples of quadratic surds. And let us see the next type of surd, that is of cubic surd. Cubic surd means what? A surd of order 3. A surd of order 3 is called as a cubic surd. A surd of order 3 is what? Cubic surd. That means cubic root of 10, cubic root of 70. Likewise, that means if order 3, if a surd whose order 3 is called as a cubic surd. Okay. Next type of is biquadratic surd. Biquadratic surd means what? A surd of order 4. A surd of order 4 is called a biquadratic surd. Okay. Example, 4th root of 3. Okay. 4th root of 7 and 4th root of 9. Here you need to understand that square root of 9, which is not a surd, which is a rational number, but cubic root of 9 is said to be what? Cubic surd. And 4th root of 9 is said to be what? Biquadratic surd. This is said to be what? Biquadratic surd. Okay, is it clear? Next, types of surds based on terms. Now let us see the types of surds. Based on terms. Based on number of terms, we can classify this surds. Okay, first type is a simple surd or monomial surd. Simple surd or monomial simple surd or monomial surd. When a surd is said to be a simple surd or monomial surd, here you need to understand that monomial. Monomial means what? 1. Okay, so a surd which is consist of a single terminate, it is called as a simple surd or else monomial. A surd consists of single terminate, then it is called as an simple surd or monomial surd. Okay, this is about the simple surds. So let us see some examples of simple surds, that is square root of 3 and cubic root of 4 and 5 into cubic root of 9. And you might have wondered that this example, okay, in the first two examples we have only one term, that is of square root of 3, square root of 4, but in this we have 5 into something we have written, 5 into cubic root of 9 we have written. Don't consider that this surd is having two terms. Actually terms are separated by plus or minus. That means if the before the plus one term, after the plus one term, in the same manner before the minus one term, after the minus one term, likewise that terms will be separated. Here there is no plus sign or no minus sign which separates this 5 and cubic root of 9. That means those are in the product form. That product gives you only one number. Let me take a simple example. 3 and 2. Product of this is 6. That is of one number itself. Okay, but if you may ask you, 3 plus 2 is a 5. It is also single term only, na? But this is always not true. Why? Because when you take two heterogeneous terms, that means two unlike terms that cannot be added, so then they treated as a separate terms. Let me take 3x plus 2x. These are like terms, can be added, so this can be written as 5x. But if you take 3x plus 2y, this cannot be added. That's why these are said with what? Separate terms. That's why you need to see that when the two like terms are joined with the positive sign, add them and take that as a common, add them taken as a sum, then that sum will be treated as only one term. But if you take unlike terms like this, when they are joined with an addition form, then we treat them as a two terms. Here there is no addition sign, so this is said to be what? Only one term. That means this surd is having only one term. That's why it is an example of a simple surd. Okay, now let us see the next type of the surd. Let us see the next type of surd, that is a pure surd. Pure surd means what? Okay, let me say the definition of a pure surd. A simple surd is said to be as a pure surd a simple surd said to be as a pure surd if the coefficient of the surd is 1. If you take a nth root of a surd, okay, so this is said to be pure surd. Why? Because it what is the coefficient of this nth root of a? There is no other number which is multiplying to this, so we'll take it as a 1. So if the coefficient of a simple surd is 1, then it is said to be as a pure surd. Let me take a simple examples. For the simple example, we have taken examples like this: square root of 3 and square cubic root of 4 and 5 into cubic root of 9. These are the three examples we have considered for the simple surds. And if you observe this example, in this example square root of 3, for this what is the coefficient means there is no other number which is being multiplying to it, so we should take it as a 1. So as a coefficient of this as a 1, so it is said to be what? Pure surd. It is said to be what? Pure surd. Okay, and this is also example of pure surd. But here what is the coefficient of this surd part? That is 5. So then it is not a pure surd. It is not a pure surd. Okay, clear? Do you understand now? Let me take another type of examples. Let me explain another type of example, that is of a mixed surd. It's a mixed surd. Mixed surd means what? A simple surd which is not a pure, surd. A simple surd which is not a pure surd is called as a mixed surd. Just now we took examples. We took that examples as cubic root of 3 and cubic root of 4 and 5 into cubic root of 9 we have taken. Now these two are the examples of pure surd. These two are examples of pure surd, and we discussed that this is not a pure surd. This is not a pure surd. If it is not a pure surd, then what type of surd? Then if a simple surd is not a pure surd, if it is not a pure surd, then it is said with what? Mixed surd. It is said with what? Mixed surd. So let me give you a few more examples for the mixed surd. That is of 2 into root 3, nice, 4 into 7th root of 9, and 6 into 6th root of 18, so on. These are the examples of few simple surds, mixed surds. Now let us take another type of surds, that is of compound surds. Compound surd. Okay, compound surd means what? A surd consists of 2 or more terms in it, then it is said without compound surd. Compound in the sense more than the one. Compound in the sense itself. What is the meaning of compound? Compound itself says that more than the one. That means if a surd consists of more than the one terms, if a surd which is consists of more than the one term, then that is said to what? Compound surds. Okay, let me read the definition. A surd consists of 2 or more than the 2 terms. A surd which is consists of 2 or more than the 2 terms, then is called then compound surds. This is said to what? Compound surd. Okay, examples of compound surds: 3 plus 2 root 2, okay, and root 2 minus root 3, 4 plus root 3 minus root 7, and so on. These are the examples of compound surds. Now let me explain another type of surds, that is of binomial surd. Binomial surd. Okay, so bi means what? 2. That means if a compound surd consists of 2 terms in it, if a compound surd consists of only 2 terms in it, then that compound surd is said to be as a binomial surd. if a compound set consists of two terms in it. So let me write the definition. A compound set consists of two terms is called as a binomial set. Okay, the compound set consists of two terms, then it is said to be a binomial set. Okay, example for binomial set, that is of root 2 plus root 3 and 2 minus root 7 and 3 minus 4 and so on. Okay, here in the binomial terms, in the binomial sets, it is not necessary that two terms are sets. Okay, if you take this first example, in the first example we have root 2 plus root 3. Here root 2 is a third and root 3 is also third. But if you take a second and third examples, in which first term is a rational number and second term is a third. Okay, that means in the binomial sets, it is not necessary that two terms are sets. Okay, now next type is what? Trinomial. Binomial means what? A compound set which is consist of two terms. If it has three terms, if a compound set which is having three terms, then that is said as what? Trinomial sets. Okay, example, let us say that examples of trinomial sets: 2 minus root 3 plus root 5 comma 3 plus root 10 plus 3 root 20 and so on. These are the simple examples of a trinomial sets. Okay, now next concept that we are going to discuss as a similar sets or like sets, which is a very important topic to solve the problems of sets. Okay, so next type is what better? That is a similar sets or like sets. Okay, so let me connect this like sets concept with the examples of like fractions. Okay, we already know that the like fractions, when the two fractions are set without like fractions, when the two fractions are set with the like fractions, two fractions are said to be as a like fractions if the fractions are having same denominator. Let me take an example: 2 by 5 and 7 by 5. If you take two fractions, 2 by 5 and 7 by 5, these two fractions are having same denominator. These two fractions are having same denominator, that is as a 5. So these are set without like fractions. But if you take a 2 by 5 and 7 by 3, if you take, these are set without unlike fractions. These are set without unlike fractions. So in the same manner, like terms means what, or like sets means what? Let us discuss that. Like sets means what? With the simple examples, let us discuss. Okay, so let me give a few examples for like sets. Like sets means what? The sets which are having same simple set. The sets which are having same simple sets are said to be what? Like sets. See this: root 3, 2 root 3, 4 root 3, 19 root 3 and 2020 root 3. If you observe these all the terms, if you observe these four numbers, these four are said to be the terms or else sets. These all sets are having same simple set as a root 3. Okay, so these all sets are having same simple set as a root 3 with a different coefficients, with a different multiples. That means if two or more than the two sets are said to be as a similar sets or like sets if they are different multiples of same set. Okay, is it clear now? If they are different multiples of same simple set, then that surds are said as what? Similar surds or like surds. Okay, let me write the definition of simple surds. Okay, if two surds are different multiples of a same simple surd, then they are said with what? Similar surds or like surds. Okay, and here what is an importance of simple surds? Means simple surds can be added, or that means similar surds can be added, but dissimilar surds or else unlike surds cannot be added. Same as a fractions. In the fractions we can add only like fractions. Okay, by taking common denominator and add the numerators, so that you will get a 9 by 5. But if you are supposed to add unlike fractions like 2 by 5 and 7 by 3, if you want to add them, firstly we need to make them into like fractions. To that we will take a LCM, that we all know. Here also we can add only simple surds. We cannot add, or else we can add only like surds. We cannot add unlike surds. Okay, let me take an example. If you take a 2 root 3 plus 4 root 3 and adding them, you can write it as a 4 root 3. But if you take a 2 root 3 plus 5 root 6 is that. Okay, this cannot be added. These two cannot be added. Why? Because this is a multiple of root 3, this is a multiple of root 6. That means these two are not like surds, so they cannot be added. That's why it is very, very important. Okay, so these are the main important concepts regarding to the surds. Okay, in the coming videos we are going to solve a few problems based on these important synopsis.